Hi everyone, Assalamualaikum. In this video, we will continue with example 3 under linear equation for first order ODE. Find the solution for the given linear differential equation sin x dy over dx plus y cos x equals to sin 2x, right? From the given question here, we have term containing y to the power of 1. And for the other term, there is no term containing y, right? So this is linear equation, okay? And to solve linear equation, first step, we need to write into the form of dy over dx plus pxy equals to qx, okay? Please note that the coefficient of dy over dx should be positive 1, right? From the given question here, the coefficient of dy over dx is sin x. So, we need to divide each term by sin x. Okay? So, we get this. Okay? We divide each term by sin x. Right? After that, we simplify, then we get this. Right? Right, we simplify sin x over sin x. We get 1 here. No need to write positive 1 here. And then cos x over sin x equals to cot x. And then we can write sin 2x using double angle identity equals to 2 sin x cos x. Right? This comes from double angle identity. Sin 2x equals to 2 sin x cos x, right? Right, why we write sin 2x equals to 2 sin x cos x? Because we can simplify sin x in numerator and sin x in denominator, right? So after we simplify, we get this. Dy over dx plus cot x times y equals to 2 cos x, right? And after that, step 2. We identify px and qx, right? Right, so our px, first we compare dy over dx and dy over dx here. Now the coefficient of dy over dx equals to positive 1, okay? And then we have plus sign, and then our px equals to cot x, okay? Px should be the term beside y. Yeah, so we put here our px equals to cot x and our qx equals to 2 cos x. Right? Right, after that, we continue with step 3. Find integration of px dx. Right? From the previous slide, our px equals to cot x. Right? So now we integrate px dx means we integrate cot x dx. Right? To integrate cot x dx, we need to change cot x equals to cos x over sin x. Right? For quick method, okay, we can use, okay, now we have numerator is a derivative of denominator, because when we differentiate denominator sin x, the answer equals to numerator cos x. Alright? Alright, if we have numerator is a derivative of denominator, so the answer equals to ln denominator. Okay? So the answer equals to ln denominator equals to sin x. Okay? Alright, plus C, and then no need to put plus C because we still not finish our solution. This is the quick method. Okay? When we have numerator is a derivative of denominator, when we integrate means the answer equals to ln denominator. Okay? This is a quick method. Okay? Or we can integrate cot x dx using U substitution. Okay? First, we write cot x equals to cos x over sin x. Okay? And then, we choose u equals to sin x. After that, we differentiate u with respect to x. So we get du over dx equals to, we differentiate sin x equals to positive cos x. And then we write dx as a subject. So we get equals to du over cos x. We cross multiply. After that, we substitute back, okay, into integration of cos x over sin x dx. We still have cos x in numerator, and then over, we replace sin x equals to u, and then times, we replace dx equals to du over cos x, right? Right, after that, we can simplify cos x and cos x here, okay? If we choose the correct u, we can simplify all terms containing variable x, and we can rewrite in terms of u and du. Now, after we simplify, we get integration of 1 over u du, right? No more variable x. So now we can integrate with respect to u, okay? When we integrate 1 over u du, the answer equals to ln u plus c. After that, we replace back our u equals to sin x. Okay, so the answer equals to ln sin x plus c, but no need to write plus c because we still not finish our solution. Okay, when we compare, the answers are equal, right? So we can choose either using u substitution or using quick method. Using quick method, the technique is the numerator, when we integrate, the numerator equals to the derivative of denominator. So the answer after we integrate equals to ln denominator, right? Right, after that, we continue with step 4. Find integrating factor if equals to e to the power of integration of px dx, right? So, if equals to, after we substitute, we have e, and then from the previous slide, integration of px dx equals to ln sin x, right? And we can simplify this. So, we have sin x, okay? We simplify this using this formula. If we have e to the power of ln x, the answer equals to x. Why? You can try using your calculator. Let's say you just replace x equals to 2. Okay, using calculator, if we calculate e to the power of ln 2, it is equals to 2. Let's say if we replace x equals to 3, e to the power of ln 3 using calculator will give the answer 3. That's why the formula is e to the power of ln x equals to x. So using this formula, if we have e to the power of ln x, it is equals to x. But make sure that the coefficient of ln should be positive 1. So now we have the coefficient of ln equals to positive 1. So we can refer from this formula. Okay. So from here we have e to the power of ln sin x. And now our x equals to sin x. So it is equals to sin x after we simplify, right? So now our if equals to sin x. Okay. After that, we continue with step 5. The solution is y times if equals to integration of qx times if dx. Okay. Right from here, we have y times, we replace if equals to sin x equals to integration of qx. Qx from the previous slide equals to 2 cos x. And then times if. We replace if equals to sin x. And then we have dx. Right? Right. Or we can write y sin x equals to integration of 2. We just replace x, sin x in front here, and then cos x, and then dx. Right? Right, after that, from double angle identities, okay, 2 sin x cos x equals to sin 2x. Okay? So, we can write y sin x equals to, we replace 2 sin x cos x equals to sine 2x, right? Because sine 2x equals to 2 sine x cos x using double angle identity, right? Right after that, from here, we can refer formula integration of sine ax dx equals to negative 1 over a cos ax plus c. A means constant. When we compare from here, our constant a equals to 2. Okay, we no need to integrate the function on the left hand side because there is no integration sign. Okay, so on the left hand side, we still have y sine x equals to, and then we integrate sine to x dx using this formula. After we integrate, no more integration sign. So using this formula, we have negative, and then 1 over a means 1 over 2, and then cos ax means cos 2x. And then after we done integrate, we put plus c at the back, right? Right, so from here, this is our final answer. This is called the general solution, right? We no need to find the value of c because there is no initial condition. Okay, the initial condition is not given in this question. So we no need to find the value of c. This is called the general solution, right? This is our final answer. We done solve this ordinary differential equation because there is no more dy over dx symbol, right?
Coming up next, more examples for linear equations. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.